Hello and welcome to my presentation for CA684 Machine Learning. My name is John Coleman and the topic of my presentation is Twitter Sentiment Analysis for Brand Popularity. It's a single person project, so I don't have a video recording, it's just on screencast. So I've placed a picture of myself there, and a bit about my background is I am an electronic engineer, qualified from DIT. I did telecoms in Ericsson for 15 years. Last year I completed a graduate diploma in IT at DCU, and this year I'm a full-time data analytics student. As I mentioned, the project is just myself as a single member. So why did I pick this area for a project? Well, I was interested in social networking. As we know, the more and more connected society gets, the more and more people are using social media. In 2017, there was an estimated 2.51 billion people using social media. In 2020, that's due to grow to over 3 billion. Twitter alone, which is the platform I've chosen for this project, has 319 million active subscribers. So there's huge commercial opportunity here. If companies could accurately reflect people's opinions of their products from Twitter feeds, I think there's a huge commercial benefit. People are offering their opinions for free on these platforms. Their data is made public instantly, and the company also gets feedback instantly from new products or new brands. So the Oxford English Dictionary, they define sentiment analysis as the process of computationally identifying and categorizing opinions expressed in a piece of text, especially in order to determine whether the writer's attitude towards a particular topic, product, etc. is positive, negative, or neutral. So we can see here that the key phrases are that the question is, can we identify or can we categorize the opinion of a piece of text? And by categorize, we mean, can we say that it's positive, can we say it's negative, or can we say it's neutral? So the idea then of this project is to see if we can get Twitter data and categorize the tweets from Twitter into one of these three categories. The issues with Twitter data. Characteristics are that the maximum character limit we have is 140. So this is a particularly short string of data in order to get an opinion from. It's also scattered with lots of misspellings. There's no restriction on what type of words people can put in. So it's not just from an English dictionary vocabulary. People also put in a lot of emoticons. These are smiley faces, happy, sad faces. And there's also a lot of hashtags, which are just random words thrown in with the hashtag thing. Another issue that we have with Twitter is that Twitter datasets are not really made public. There is an API where you can download tweets, but you can only do so in batches of maybe 100. And they also set daily and weekly limits, so daily you can only download 1000 tweets. I did start this process of downloading and manually tagging tweets, positive, negative, and neutral, but as a one-person project it would have taken far too long. So with a bit of research I found this data set on Kaggle, which was used for this project. So straight away when I started doing research, I could see that sentiment analysis, or otherwise called opinion mining, it's a very wide area of study. And there's been a lot of research put into this area. There's also a lot of commercial products available. Lots of companies are claiming that they can predict the opinion on different social media reviews. In the research as well, I came across three methods that were common in almost all of the research papers that I wrote or that I read. They were naive Bayes, maximum entropy, and support vector machines. Some of the approaches I've seen to sentiment analysis in the past were, especially with regard to Twitter, where they took the emoticons, these are the smiley faces or sad faces that you see in the tweets, and they used these to categorize the texts. So anytime there was a happy face, they said it was a positive tweet. When it was a sad face, they said it was a negative tweet. So they categorized their tweets. They made a generalization and categorized them like that. Then other times I've seen research where to get their features, they've just solely taken the hashtags out of the tweets. So any word that had a hashtag in front of it, they've done analysis by using only these words in the tweet. They've also done feature selection based on unigrams or bigrams, and also using part of speech. Because the research papers that I read so far had most success with naive Bayes, that's the model or the method I'm going to use. And I'm going to use it with a unigram approach and a bigram approach. I've also found a library in Python called TextBlob, which instead of training the model, it actually uses an inbuilt sentiment dictionary that it already has. So I'm going to try and run the test data against TextBlob and make a comparison to see if the trained data in naive Bayes compares favorably with the untrained comparison we make in TextBlob. I'm also going to take a slightly different approach to what I've seen in the research. Some of them were categorizing their data based on emoticons, which they said themselves ended up to be too general. You can't say that a tweet is positive just because there's a smiley face somewhere along the string. They've also said that taking the hashtags and taking those words alone was not enough data. So what I'm going to do is take most of the tweet. I'm going to take all the words in the tweet, except of course for things like usernames, emoticons. I'm going to remove URLs. I'm also going to include a list of stop words, most common words like de, and, at, if, for, etc. And I'm also going to correct some spellings. Sometimes people will spell words maybe such as happy with maybe 3 or 4 or 5 P's. I'm going to correct those spellings so the happy has at most 2 P's. So just to summarize, we take the Kaggle Airline Twitter sentiment dataset. There's 14,485 rows of data. We split this into 80% training, 20% test. I'm going to remove non-essential features from the tweet. As I've said, usernames, stop words. And then we're going to compare this with the original sentiment value from Kaggle. The Kaggle dataset itself comes with a sentiment value already set for all 14,485 tweets. This has been manually selected, so we'll consider this as a true sentiment value, and we'll compare our naive Bayes model and our TextBlob model to the true sentiment value from the Kaggle dataset. So for the experiments themselves, we're going to use the Kaggle dataset. The modeling is done all through Python. I used Jupyter Notebook as well. I'm not overly familiar with Python, so Jupyter was very helpful in testing and teasing out the code until I could get it to work correctly. So in Python 2.7 we've used libraries such as Pandas, NumPy, sklearn and Natural Language Toolkit, etc. Then at the end we're going to compare the results from the Python modeling back with the original Kaggle dataset sentiment value to see how accurate our modeling has been. So I want to try and answer 3 specific questions. I want to see how accurate the naive Bayes classifier model is. Can it predict the sentiment of the tweets in the test data? Then I want to see if the unigram or the bigram approach for naive Bayes works best. So we're going to do two different models, feeding it single words and then feeding it 2 words or bigrams. And then the third question is that we're going to compare the naive Bayes model, which we've trained. We're going to compare that against a natural language processing library in Python called TextBlob, which doesn't work on any specific training. And we're going to see if it can guess the sentiment as well as the naive Bayes model. So the coding part of the project was a success, and I was able to use Python to get a successful scripts running, and we got some results back. The first question was how accurate is the naive Bayes classifier model? Well, we can see we ran it for the unigram and bigram approaches. The tables on the right tell you how many tweets that it guessed correct and how many tweets it guessed incorrectly. So we can see for the unigram model we've got 75.2% accurate. That seems to be in line with a lot of results that I read in research. They were getting between 70 and 80% accuracy. The bigram approach slightly lower, 65.4%. This is probably down to the amount of tweets that we fed into the training model. I did read research where it suggested you'd need up to 40,000 or more tweets before you could rely on the bigram model due to the sparse nature of the bigram data. So question 2 then, does the unigram or bigram approach work best? By a margin of nearly 10%, we can say that the unigram model has worked best. And for the third question, I used the TextBlob library in Python, and I ran in the same test data as I did for the naive Bayes models, and I got accuracy levels of 42.98% for the unigram and 45% for the bigram. Interestingly enough, for the bigram, the percentage was higher than the unigram. This may suggest that TextBlob have a larger library and the bigram actually works slightly better. However, overall, naive Bayes was the best model when I compared the two. This was to be expected because the training data that we put into naive Bayes was based on airline sentiment tweets. So it seems to be important that for any sentiment analysis you're doing, that you train the model with the type of language that is going to be expected in its tweet. So if you're looking for sentiment analysis of movie reviews, you should train the model with previous movie reviews. In our case, it was airline data, so we trained it with specific airline tweets. So just to conclude, this was a single person project. I found the workload was quite heavy for one person. I probably should have grouped up with somebody else. I lost a lot of time on the Twitter API, trying to categorize tweets that I pulled off for Aer Lingus and Ryanair. It took a lot of time. If I did have more in the group, I probably would have tried maximum entropy and support vector machines. Overall though, the project was a success. The coding ran correctly, the experiments were okay, and the results I got seemed to be in line with the research I got, so I was quite happy with that. And my final thoughts on the whole project were that there seems to be massive potential for commercial value for this type of sentiment analysis. I could imagine if you could combine many different models and maybe get an average of the opinion from the different models, you could increase the accuracy. Although 75% of what we got with one model was pretty decent. And I would imagine if you could train the model using big data, or you could get hold of a lot of extra tweets, that accuracy could be increased. So I see lots of commercial value for our sentiment analysis. Thank you.